Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing the D flip-flop. D stands for data or delay. So we are discussing the D flip-flop. So before going to discuss about the D flip-flop, this D flip-flop is the SR flip-flop itself with some minor changes. So when we analyze the truth table of SR flip-flop, if we are giving the S value as 0 and R value as 1, then the output will be 0. And if we are giving the S value as 1 and R is 0, then the output will be 1. So these two conditions are implemented in a D flip-flop. So that's why this flip-flop is known as a data flip-flop. And if we are not providing a clock signal, then that particular value will be stored in a D flip-flop. And if we are analyzing the truth table of SR flip-flop, the 1-1 condition shows an invalid condition, and this is not used in a SR flip-flop, and the 0-0 condition yields in the memory condition. And here also there is a condition that if we are providing a clock signal is 0, then also the previous data value will be stored. Thus the 0-1 as well as the 1-0 conditions in ASR flip-flop is providing a particular output. That's why this can be implemented with the help of a D flip-flop. So in the case of S equal to 0, then we can see that the R value is 1, and if S equal to 1, then the R value is 0. So thus we can tell that the R value is just the complement of the S value, or R is just the inverted value of S. So this principle is implementing in D flip-flop. So if we are analyzing the symbol of SR flip-flop has 5 pins, a set pin, reset pin, and a clock pin, as well as it can see 2 output pins. Those output pins are output as well as a inverted output pin. So as we mentioned, this SR can be converted into a D flip-flop by simply introducing an inverter at the input pin. So if we are providing a inverter at the S input and the output of that inverter is given towards the R, then this SR flip-flop can be easily converted into a D flip-flop. So the data value D is given towards the pin set pin, and the inverted of that particular data pin is provided towards the reset pin. So simply we are introducing a NOT gate at the data pin, and the output of the NOT gate is providing towards the reset pin. Now let us analyze what will happen if the D value is 0 as well as the D value is 1. So if we are providing a D value is 0, then automatically the S value will become 0 as well as the R value will become 1. And if the D value is 1, then the S value will be 1 and R value will be 0. The condition of SR flip-flop 0-1 as well as 1-0 can be implemented by this simple input value. So this symbol can be simplified as shown in this figure. So here we can see 4 pins in the symbol. 1 pin is for data pin, second one is for clock, third one is for output, and Q dash is for inverted output. So this is a symbol of D flip-flop. So when we come to the truth table of this D flip-flop, so before that we are going to discuss about the circuit diagram of D flip-flop. So if we are analyzing the circuit diagram of D flip-flop, it is a SR flip-flop itself. There is one and only one change, that the ES input is knotted and given towards the R. That means that this S is treated as D, and an inverter is given at the D input pin, and the output of the inverter is fed towards R flip-flop. So this is how we are representing a D flip-flop. This D flip-flop is the SR flip-flop itself. So the truth tables are deriving from the SR flip-flop itself. So before going to the D flip-flop's truth table, kindly go through the SR flip-flop, which we had analyzed in the last 2 set of lectures. So before going towards the truth table of D flip-flop, kindly go through those lectures. And if we are going towards the truth table of D flip-flop, we are starting from the SR flip-flop itself. So if we are providing a clock signal as 0, so in the SR flip-flop, if we are providing a clock signal as 0, then we are dealing with the memory condition. Here also we can tell that if the clock is 0, then there will be a memory state, that is the output will be the previous state itself. There is no change of output, thus we can tell that the previous output will be stored, that is we are dealing with a memory state. So next we are going to deal about if the clock is 1 as well as the data value is 0. So as we seen here, if the data value is 0, then the decomplement value will be 1. That simply means that we are dealing with SR flip-flop with S value equal to 0, R value equal to 1. If we are analyzing the truth table of SR flip-flop, S value equal to 0, R value equal to 1 means that the output will be 0. Thus, the truth table of D flip-flop with the clock is equal to 1, D is equal to 0 will be the output of Q equal to 0. And the next case is if clock equal to 1 and D is equal to 1. If the clock value is equal to 1 and the data value is equal to 1, then the decomplement value will be 0. That means the SR flip-flops S value is 1 and R value equal to 0. So if we are analyzing the truth table of SR flip-flop with S equal to 1 and R equal to 0, the Q value will be 1. This simply means that the D flip-flop's truth table with clock equal to 1, D is equal to 1, then the output Q is equal to 1. So this is how the D flip-flop is working. So D flip-flop is having 3 states. If the clock value is 0, then the D flip-flop will store the previous data value, that is we are dealing with a memory. And if the clock value is 1, we can see 2 different cases with the D is equal to 0 and D is equal to 1. If clock is equal to 1 and D is equal to 0, then the output will be 0, and clock equal to 1 and D is equal to 1 deals with output of 1. That is, if we are providing an input, that particular input will be provided towards the output, that is the output is equal to input itself if the clock value is 1. And if the clock is 0, then that previous output will be preserved or stored, that is we are dealing with the memory condition. So this is the circuit diagram as well as the truth table of D flip-flop, and this is how we are symbolizing the D flip-flop in a particular logic. So my dear students, hope you had understood this topic. So dear students, kindly write down the assignment question. Our assignment question is write notes on D flip-flop. And dear students, in the upcoming lecture we are discussing the excitation table as well as a characteristic table of this D flip-flop. So dear students, see you soon. Until then, goodbye, thank you, and all the best.